we're discussing the good choice of the diagonalizing a matrix or a mixing matrix and solving the problem in the basis where the relationships are diagonalized, it brings up to the following problem. Imagine that we have a matrix A, diagonalized version, it has eigenvalues which are 2 and 3. And matrix B, it can have eigenvalues which are 0.1 and 0.2. Now, as n is increasing too fast, we might notice that these quantities will increase exponentially. But these quantities of whose relationship is described by matrix B, those are going to converge fast to 0. Now, these types of problems where we do not run the risk of diverging to unreasonable large numbers, these are called the problems of Markov chains. Okay, Markov chains, they are represented by Markov matrices. And Markov matrices, they have this property that the sum of the columns, these are all equal to 1. Okay, so if you hear this the term of Markov matrices, you just immediately think, okay, it's a Markov matrix. Let me check the sum of all the elements in one column. They should be equal to 1. If this is the case, then the first eigenvalue is going to be equal to 1. Okay, and the other eigenvalues I, lambda I, for I larger or equal to 2, they are all smaller than 1. Or let me write it like this, lambda I, they are smaller than 1. Okay? So this is all, in a very concise form, what goes on with Markov matrices. Okay? They are for real problems because, and the reason for this, it is easily noticed that any Markov matrix, if we diagonalize it, it will have one eigenvalue which is 1, the rest will be smaller than 1. And we discussed about what can go with these types of matrices as n increases too fast. Let's imagine for a moment that we have 3 companies, okay, and these 3 companies, someone is analyzing how the customers can move from company A to company B, let's say to company A. So let's imagine for a moment that from company A to A, we have 0.7, which means that 70% of the customers of this company go to stay in the same company. Okay? Then to company B, let's say that from company A, we have 20% of the customers go to B, and 10% of the customers, like 0.1, they go to company C. They go to C. Then from company B, they go to A with a rate of 15%, 0.15, and then 80% they stay in their own company. They are loyal, and the 5% they go to company C, to the third one. And then from unit C or from company C, 3% or 30% go to A, 20% go to B, and 50% they stay in the same company, in the same house. Then, so this is the problem, and then we can evolve the problem like more. Check how does the number of the customers in each company, how it is going to change after a long time. If we start with, given that x0 is equal to 0.5, 0.4, and 0.1. So in principle, we're saying that initially, all the customers in a community or in a certain city, 50% of the customers are in A, 40% are covered by company B, and 10% belong to the third one. The question is, what happens to the population or the population of the customers? How are they distributed along different companies? Okay, that's the question. Then all we need to do is the following. We have the matrix A, and then we need to determine the characteristic polynomial. So we know what to do. 0.7 minus lambda, 0.15, 0.3, this is 0.2, here 0.8 minus lambda, 0.2, 0.1, 0.05, and 0.5 minus lambda. Okay, so this is the 3 by 3 matrix A minus lambda I. We need now to determine the determinant of this matrix, and we're going to get the characteristic polynomial. So this leads us, over there, this here, this leads us to a characteristic polynomial of third order in lambda, which is equal to, let's write these values if I find it. This is equal to minus lambda cube plus 2 lambda squared minus 1.24 lambda plus 0.24. Okay, so this is the characteristic polynomial, and the roots, we expect to get 3 roots out of this characteristic polynomial, because the matrix is 3 by 3. Now, since this is a Markov matrix or Markov chain related matrix, we look at the sum of the feature of 0.7, 0.91. Here we get another 1, and here we get 0.3, 0.2, 0.5. This is also 1, which means that lambda equal to 1 is a root. Okay, if lambda equal to 1 is a root, well, let's check. Is 1 really a root? Let's substitute 1 in here. So here we get minus 1 plus 2, because this is minus 1 to the power 3. Well, let me write it like this: minus 1 to the power 3 plus 2 times 1 squared minus 1.24 times 1 minus 0.24. Is this equal to 0? So minus 1 plus 2 is 1. Wait a second. Yeah, this is 1 minus. Wait a second. I have this is plus 0.24. This is plus 0.24, and this minus 1 plus 0.24 is minus 1.24. Minus this is equal to 0. So we're asking this. This is confirmed. This means that lambda 1 is a root, because we give this here, right? And we confirm that this is the case. If lambda 1 is a root, this implies that lambda minus 1 is a factor of the P3 in lambda, is a factor of the characteristic polynomial. So what we can do here is that we can divide this polynomial by lambda minus 1. Okay? If we divide this by lambda minus 1, we can find what is the ratio here, or what is the result here. And what we find is that this is lambda minus 0.6. This is lambda minus 0.6 times lambda minus 0.4. So it looks like we find that the diagonal, given that this is the matrix which represents how the customers move from one company to another, we can immediately derive that the matrix D, which is going to diagonalize the system, is the following: 1, 0, 0, 0, 0.6, 0, 0, 0, and 0.4. Okay, so this will be the D matrix. Now, if this is the D matrix, we have to try to solve the problem. Now, one thing that we can use, well, we can do the following. If we are given x0, we can follow a similar schema. So we have x0 in the original basis, where we have also a. So this is, we are here. We go and find the u0 in the new domain, where the problem is described by the matrix D. Then we need to find the ut. How does this one evolve in time? And then we come back and find xt. Okay? So this is how we can move across. And this means that from x0, which is a given number, we can move this way with p inverse. Here we multiply with d to the power t, and here we move with the matrix p. The other choice, it would be the following. We could just multiply x0 with 8 to the power t. So we can multiply it with 8 to the power t, and we can get this number. But the path in blue, it is more efficient in terms of computational time or in terms of difficulty. Now that we have d, we need to determine also what is the matrix P, which is composed of the eigenvectors. The matrix P is 3, 4, 1, 3, 4, 1, 3 minus 4, 1, 3, minus 4, 1, minus 1, 0, 1. And, wait a second, so then we need also what is P inverse. P inverse is equal to 1 over 8, because that's the determinant of the matrix P, times 1, 1 minus 2, 1, 1 minus 2, 1 minus 1, 0, 1 minus 1, 0, 1, 1, 6, 1, 1, 6. Okay, so here we have the P inverse. Then, next step, let's find U0. U0 is equal to, let's say, 1 over 8. Or you know what? In order to save also some effort, we just multiply the P inverse with the initial state, which is 0.5, 0.5, 0.4, and 0.1. Okay. So this multiplication, this gives for us the U0. The U0 is going to be equal to 0.12.5, 0.12.5, 0.025, and minus 0.05. Okay, so this is the initial condition in this domain. This is the U0. Then immediately, so let's take this out. Now that you know U0, we need to determine what is UT, okay? And UT, it will be simply reported as, wait a second, so it will be dt, dt times U0. This is equal to 1 to the power t, that's 1. 0, 0.6 to the power t, 0, 0, 0.4 to the power t. And we multiply these two together, and with okay, and then we find that ut is equal to 0. So we get the single vector 0.125. Then we multiply the second row with the single column that we have. We find this is 0.6 to the power t times 0.025. Okay, and then the third row, it's minus, this is 0.4 to the power t times 0.05 with a negative sign. Okay, so you can put the negative sign wherever you think it's possible. So this is ut. Okay, and then I think we solved the problem. We just need somewhere around. The moment we found u0, we were at this point. Now that we found ut, we are here. Now we are left with xt. What is xt? Xt is going to be equal to p, which is 3, 4, 1, 3, 4, 1, p minus 4, 1, minus 1, 0, 1, times these values, which are 0.125, 0.6 to the power t times 0.025, and minus 0.4 to the power t times 0.05. Okay, And this will be equal to, this is equal to, now, sometimes I'd like to think of this problem the same way that we consider the column space. So if we multiply a matrix A with any vector x, what is the result? The result is going to be a vector B, which is a linear combination of the columns of A. So here, the columns of A are here, okay, are this and this. So the linear combination, it will be this number times the first column, plus the second value times the second column, plus the third value times the third column, okay? So then, this solution is going to be, the final solution is going to be 0.125 times the vector 3, 4, 1, plus 0.6 t times 0.025 times the second column, 3 minus 4, 1, 3 minus 4, 1, plus, this is minus 0.4 to the power t times 0.05 times the third column, which is minus 1, 0, 1. So now, so this is how we can represent this. But at a long time, only this term will survive, okay? So, because 0.6 to the power t, so this is a very small number, we argue regarding this, and also 0.4 to the power t, also this is going to converge to 0. So then we can say that xt, after a long time, now actually when we say long time, this is the same way as you can consider infinity. So forever, much later, the population here, or the number of customers in the first store A, this is going to be 125 by 3, 125 by 3, this is 0.375, 0.375, and multiplied by 4, this is 2.55, this is 0.5, and then we get 0.125, 0.125. So this is the final answer, and let's remember that we started from x0, which was equal to 50%, 40%, and 10%, 0.5, 0.4, and 0.1. So apparently, provider B increased after a long time, increased the customer number from 40% to 50%. The third store or the third company gained some customers that most probably got them from the first company, because the first company it lost from 50% to 37.5% of the customers. Do you have any question? If not, we can give another break.